All right, let's continue with this rational expression stuff, and we're going to do some multiplication division. And this is actually easier than the addition and subtraction. When you get into the addition and subtraction of fractions, and don't you find that true when you're a kid, when you're growing up learning how to do fractions? The multiplication and division was a little easier than adding and subtracting fractions. Because what was the big deal about adding and subtracting? Common denominators. And for some reason, people have a difficult time finding common denominators and all that. You don't have to do that with multiplication and division, and that's kind of nice. So let's do a couple examples here, and we'll see how that goes. So here's a multiplication problem. You're multiplying fractions. 8 and y to the 5th. And this will say, it'll say multiply or divide, or sometimes it'll even say simplify, or they just might say multiply. Okay, there could be a couple different things that they could say here. So we're going to multiply these together. Now, when you first learn multiplication, for instance, if I had something like this, if I had 3 halves times 5 sevenths, and I asked you to multiply these two things together, remember what you first were told when you first learned this stuff? Just multiply straight across. Remember that? So you multiply straight across. 3 times 5 is 15. 2 times 7 is 14, and you just leave it like that. Right? Now, when you're in elementary school, they probably always made you turn it into an improper or a mixed number, but in algebra, I'm okay if you just keep it improper like that. So that's how they taught you how to do this. But what if you had something like this? What if you had 3 over 2 times 8 over 12? Okay, let's do that. Actually, let's not use 12. Let's use 15, just to be different. Yeah, so what you can do here, you could just multiply straight across, couldn't you? But then your fraction may not be completely simplified. Then you would have to simplify your fraction. It's a lot easier to simplify before you actually do your multiplication, okay? Remember yesterday we said if you had something on top, for instance, if I had 2 on the top and 8 on the bottom, 2 goes into 2 once, 2 goes into 8 4 times, so it's 1/4. Everybody knows that part, right? So let's come over here. You can do the same thing. This is not cross multiplication. A lot of people mistakenly say, oh, you cross multiply. No, this is not cross multiplication. It's just dividing things out. We have things on the top, we got things on the bottom. Everything's being multiplied, isn't it? All right, so we can cancel things out by dividing them out. So look at the 3. Do I have anything on the bottom that will divide evenly into 3? 15. So 3 divides into 3 one time, and 3 divides into 15, what? 5 times. Or sometimes we kind of shorten and we say it goes into, right? You ever hear that? There was a play at my old school they put on, and I don't know, one of the scenes was, oh, it was like the Beverly Hillbillies. And one of the characters on it, he says, oh, I know all my gazintas. And he's like, gazintas? What's a gazinta? He says, you know, 2 goes into 4 2 times, 2 goes into 6 3 times. You ever hear that before? I just thought that was kind of funny. So it goes into, you know, he just kind of shortens it because they're hillbillies, okay? So, but sometimes we say that. But we just want to make sure we know what we're talking about when we say it goes into. It divides into. It divides evenly, doesn't it? 3 divides into 3 once, into 15 5 times, okay? 2 divides into 2, or goes into 2, what? Once. And 2 goes into, or goes into, what? 4 times, all right? And then, so now you have, what? 4/5. And now it's simplified, isn't it? Make sense? We're going to do the same thing with this stuff over here. All right? Except they're going to introduce not just numbers, but they're going to introduce letters and variables and all that good stuff. All right? So let's see what we can do here. Let's use a different color. Let's see what's on top. I'm not just going to multiply straight across. I want to see if anything divides out. So let's look at the 2. Is there anything on the bottom that divides into or goes into 2? The 8, right. So 2 goes into 2 once. 2 goes into 8 4 times. Good. Anything else? As far as just the numbers, let's do the numbers first, then we'll do the variables. What about 9 and 27? Yeah. Yep, 9 goes into 9 one time, and 9 goes into 27 3 times. Good. All right. Now, what about the y's? That's right. You subtract. Okay, or watch this. Let's just put this. You don't have to write this part down. I'm just trying to get us to wrap our brain around it a little bit. I have a y squared on the top and a y to the 5th on the bottom. You could subtract if you wanted to, but what's 2 minus 5? It's -3, isn't it? I really don't want to write it as a negative exponent. This is what I do. This is how I look at it. What does y squared mean? It means y times y, right? It means I have 2 y's on the top. What's y to the 5th? That means how many y's do I have on the bottom? 5 of them. They're all being multiplied, right? So this is what I do. I say 2 of these y's cancels with how many down here? 2 down here. How many of them I got left over if I take off 2 of them? I got 3 of them. Do you see that? Now, what's left on top? Is this just a nothing, a 0? No, it divides into it, what? 1 time. So make sure you put the 1 there. So really, this is 1 on top, y cubed on the bottom. So you come up here. With that said, look up here. I have 2 y's up top. I got 5 y's on the bottom. So watch. 2 of these will divide into what? 2 of these. How many do I have left over? 3 of them. I think that's the easiest way to do it. You could think subtraction, because the rule says when you divide with exponents, right, and you have the same base, you subtract the exponents. But then you might have negative exponents, and that gets a little bit weird. I like this. Now that looks kind of a mess right there, doesn't it? Yes, sir. It's not a 2y. It's not a 2y. It's a y squared. Okay. Yeah. Yeah, the y stays there. It's still y cubed, all right? Because it's like this. It's y squared is y times y, isn't it? Y to the 5th is this. So watch this. This y cancels, that y cancels, right? This y cancels, and this y cancels. So what am I left with? They went into each other 1 time, right? So 1 times 1 is 1. What do I have left on the bottom? It's not just a 3, is it? It's what? It's y to the 3rd. It's y cubed. So yeah, the y definitely stays there. It doesn't just become a 3, it's a y cubed. So you got to know really what's going on behind the scenes. This is what's going on behind the scenes. All right, but we don't have to write that out. I mean, what if you had y to the 84th and y to the 57th? You're not going to write out 57 y's and 84 y's and cancel them all out, are you? That would be ridiculous. So we got to learn a little pattern, learn a little method of doing this, and that's the method. All right, let's see what's left over. Well, the 2 canceled out completely, right? It became a 1. The y squared completely canceled out. That became a 1. The 27 canceled out, but it became a what? A 3. So I have a 3 on the top. Let's look on the bottom. The 9 canceled out to be a 1. The 8, sorry, canceled out to be a 4. And then what do we have left down here? Y cubed. All right? And so there it is. Does that make sense? All right, that was pretty simple, wasn't it? This is not cross multiplication. All right, I get that all the time. Oh, we cross multiply. No, it's not cross multiplication. Cross multiply is something completely different. All right. All right, let's do another one. Here we go. Write this down. 3m squared minus 2m minus 8 over 3m squared plus 14m plus 8 times 3m plus 2 and 3m plus 4. Alright. Now, can we start canceling stuff out right now? Oh, 3m cancels with 3m, right? 2 goes into... Why not? Why can't we cancel it out? Well, it's not really distributing. Ajay, what'd you say? It's addition. That's right, because this 3m right there is being added. Even though the 3 is being added, multiplied by the m, this whole term, this 3m is being added to something else. Okay, we talked about that yesterday, didn't we? All right, so the 3m's do not cancel out. In fact, nothing cancels out the way it is right now, does it? So what in the world can I do? We mentioned this yesterday. Yeah, absolutely. We can factor these things. Okay, these are rigged for us, so we can factor them out. All right, so let's take this top one and let's, oops, it's a little squiggly. Let's try and make it a little nicer. All right, let's take this and let's see what we can do. Now, these two you can't factor, can you? 3m plus 2. So I'm just going to keep it 3m plus 2. And 3m plus 4, you can't factor that. So I'm going to keep it like this. So let's see if we can factor these two right here. They look like our trinomials, don't they? Should be used to this by now, right? Always like to put the 2 parentheses here. When Khan did this on that lesson we just watched, he started writing the stuff in right away, but I like to start, I call it the shell. I like to start with the outside shell. Okay, put the signs in there and then think about what we're going to stick in there. I think, to me, that's just a little more organized. So let's look at the signs first. This times this has to be -8, and it has to add up to be negative. So what do we got? Well, one has to be positive, and one's got to be negative, right? If it multiplies to be negative. What about this bottom one? They both have to be positive, because they have to be a +8 when they multiply together, and they have to add up to be a +14, so they have to both be plus. There's my shell. All right, now I want to fill it in and see what we get. So the first has to multiply to be 3m squared. So I would say put 3m and m. And this has to be 8. I got a couple options. I got 2 times 4, 8 times 1, and I could always switch those around too, couldn't I? 1 and 8, 2 and 4, 4 and 2, whatever. All right, so I don't know. Let's just try one. Let's go 2 and 4. Let's see what we get there. So that's what, -12, and that's +2. Well, that sure didn't work, did it? Let's try switching the 2 and the 4 around. Put the 4 here and the 2 here. Let's see what that gives us. The outside, that'd be -6, and the inside is +4. Well, that's close. That's +2, but I want a -2. So what do you think my next choice is going to be? Yeah, change the signs. So let's make this one negative and make this one positive. There's a +6, a -4. I did it wrong, didn't I? I didn't even change them, did I? I did change them? Oh, the other way was right? I just said it wrong? My bad. Thanks for keeping track of me. Because, yeah, there we go. So I did it right the first time, right? Or the time before that. Yep, that's -6, +4, which is -2. Sorry about that. Yep. See, Khan makes mistakes, and I can make mistakes too, right? If Khan, I mean, he graduated from MIT, for goodness sakes, and he made mistakes on a little factoring problem, so I think I can make mistakes too. So -6 plus 4m, that's -2m. So that's factor, that's real nice. Let's try this one right here. So I'm going to go 3m again and m. I don't know, let's just try, let's try 2 and 4. I kind of thought ahead a little bit on this one, because this is going to be 12, this is going to be 2, that's going to be 14. So there we go, it's nice and factored. Agreed? Now look at this 3m plus 2. If you wanted to, they didn't write it like this originally, but sometimes it might help just putting that around, putting that in parentheses. It just kind of, it shows me at a quick glance that, yeah, this stuff is being multiplied. So look, all 3 things up top are being multiplied, aren't they? All 3 things down on the bottom are being multiplied. So now I can cancel stuff out. If I see the same thing on the top as I have on the bottom, sure, I can go ahead and cancel stuff out. So do you see anything that cancels? Which one? 3m plus 4 cancels. That one cancels with that one, or divides out, right? It divides into 1, right? Anything over itself is a 1. That's technically what's going on here. Anything else cancel out or divide out? The 3m plus 2. So that cancels with that. Good. And then, what do? Just write what's left over, right? m minus 2 over m plus 4. Did the m's cancel out here? No, because it's part of a subtraction or addition problem. Remember, we talked about that yesterday. They can't cancel out here. So I'm done. That's it. Now, they don't, let me see this. They don't talk, we just watched that Khan video, and he was a little bit picky about certain things on the denominator can't equal 0. Like, you can't have a denominator of 0. We're not going to worry about that right now. Okay, there'll be a lesson a lot later on where we will get a little bit picky about that, but as far as these problems, that's fine. Just leave it like this, and you're good to go. All right? That's not so bad, is it? It's just a combination of what we did in the, a few days back when we did that factoring, or a week or two ago when we did factoring, and the stuff we just did yesterday with canceling stuff out. All right? So it's really nothing that's absolutely brand new, is it? It's all kind of stuff that's being put together. We learn a little bit here, learn a little bit here, and then eventually we put a lot of that stuff together into one problem, and that's what we're doing there. That's why it's so important to stay up on your algebra, okay, and that you don't get left behind, because it all builds on itself, doesn't it? You've noticed that, haven't you? Your years of taking math? Yep. All right, look at this. Now that's not the only thing. I'm going to multiply it. This is all multiplication. Wow, look at this crazy thing. 2x. But again, there's nothing brand new on this problem. I promise you. Everything on here, even though it's going to look real crazy, everything on here we've done before. And again, that's why it's important to make sure that you stay up with the stuff that we've been doing. Don't let it just slip through your fingers, okay? Make sure you grasp it. Oh my goodness, what in the world's going on? Alright, let's take a look at this. Well, what did we do in the last problem? We can't just cancel stuff out here, can we? Alright, because you got subtractions in between, you got pluses in between here, so nothing just cancels out the way it is right now. So what do you think we might do? What do you think? Colors use blue. Yeah, let's factor. Okay, we got to factor. All these things you can actually factor. Look at this top one. It's the difference of 2 cubes. Now, I've taught this before, so I'm not going to sit here and teach this like from scratch. It's a difference of two cubes, which is that same opposite positive problem. So that same opposite positive, right? So remember, a and b go here. In this case, it's x and y. Then you square the ends, which is x squared and y squared. Then you multiply the two things together, which is x, y. That goes right there. All right? Then this bottom, this is a difference of two squares. A difference of two squares is two parentheses again, but both the parentheses look the same except one's plus and one's minus. So you got x in the first one and y in the second one. That's all review. That's why I went so fast on this. Where at? This one? Oh, sorry. My bad. This was supposed to be a y. Yeah, that would make a difference, wouldn't it? Thanks for that. Alright, now let's do this. Look at this crazy long thing. But if you look at this, this is something that we've done before. Watch this. Does that look familiar? By grouping. Alright, so I could group those and factor them out. So let's group them. What's in common with this first grouping right here? A 2. So let's factor out that. Got an x plus y. Alright, put a plus right here. And then what's in common here? Z. Alright, and I get x plus y. Alright, let's do the bottom. Let's factor out this. There's a 2 in common with this. And then I get x squared y squared plus y squared. And plus, let's group these together. What do I have in common there? Another z. And then I've got x squared y squared left there. Alright, so this is not completely factored yet, is it? Because I got a plus in between there. So I'm going to have to factor that. Now watch this. With the magic of my little program here, I can just copy and paste. Bring this down so I don't have to rewrite it again. It's too bad you can't do that, right? Now let's do this. What's in common here? And x plus y is in common, isn't it? X plus y. This is grouping. And then if I factor out an x plus y from this, I get 2 plus what? Z. And then do the same thing here. Factor out what? X squared plus y squared from this. And if I factor out an x squared plus y squared, I get a 2 plus z. How about that? I know I'm going a little quick, but that's the beauty of having this on YouTube. You can always go back and look at it, slow it down a little bit, take your time, write it down, but I need to keep moving. Now, look, now everything is being multiplied. Everything's being multiplied. It wasn't all being multiplied here because, look, I had a plus in between these, didn't I? So I couldn't just cancel this stuff out because I had pluses in between. But now everything's being multiplied. This times this times this times this. So now I can go ahead and divide things out if everything is being multiplied. So let's see if I have anything in common. This is the fun part, isn't it? Canceling these things out. I like this. Watch. I always say this. I would say bang, bang. Right? That goes. What else can you bang out here? X plus y. Bang, bang. Right there. Anything else? 2 plus z. Bang, bang. That goes. And so, what are we left with then? That x squared thing. So it's just x squared plus xy plus y squared over x squared plus y squared. And that's it. And you can't factor those. This almost looks like a perfect square right here because you can take the square root of this and square root of this. But what's our test? Take the square root of both of them, so that'd be x times y. But then what do you have to do? You have to double it, and that'll be your middle term. Is that doubled? No. So this is not factorable, okay? And the bottom is not factorable either because there's no sum of two squares. So you can't factor that any further than that. You just leave it, and that's your answer. This is definitely taking Algebra 2 just a step higher, isn't it? You probably didn't do anything quite like this in Algebra 2, but you had these basic principles, though. The basic principles that we're learning right here, you actually should have learned in Algebra 2. We're just taking it and just a little bit further, okay? All right, that's good. That's basically where I wanted to end today, all right? So that's multiplication and division and simplifying fractions. Yes? There's going to be, but we just haven't got there yet, and we don't have enough time. Oh, sorry. No, all the stuff that we covered yesterday, we basically hit today. All right, so all this, yeah. all the stuff we hit yesterday. If you understand what we did today, you definitely are okay with what we did yesterday. But you can always go back to the video, watch it, right? Skim through a few parts just to see what's going on. All right, please watch the videos. It's not because I care about how many people are watching them. I mean, believe me, it's embarrassing. I only got 1 or 2 views per video anyway. All right, so even if I get 10 views, that's crazy. That Derek Owens guy gets like 1,000 or 2,000 views per video on his. So I don't really care about how many views I'm getting. I care that you're learning the information. That's what I'm caring about. Okay, I want you to use this as a resource so that you can understand how to do these problems. Okay, and if I go a little fast in class, then you got to go and you have to watch these videos and watch them, stop them, pause them, write stuff down, use it as a study guide. Okay, take this seriously. And I'm giving you many, many resources that that you can use. You just have to take advantage of it, okay? All right, let me give you a worksheet. You should... oh, I almost forgot this real quick. I got like a minute left. This is real basic. What if I had this? Remember this from a long time ago? 1/2 divided by 3/4. You never really do division of fractions, do you? You always change it into what? Multiplication. But what do you multiply by? You multiply by the reciprocal. Good. That's a phrase that almost every math teacher uses. Multiply by the reciprocal. Okay, so the reciprocal would be what? 4/3. So now you can go ahead and multiply. 2 goes into 2 once, 2 goes into 4 twice, and so that would just be 2/3. Agreed? Now let me show you. On the worksheet, you're going to see stuff like this, but you'll see a division, right? So what would you do right off the bat? Yeah. So like this orange one right here, okay? Instead of multiply, you might see a division, but right off the bat, just flip the top and the bottom, and then you work it just like it would be a regular multiplication problem. Does that make sense? So it'll look a little more complicated, but really, you just flip it, and it's a multiplication problem, and then you're good to go. All right, so you should be able to do up to number 9, okay? It's not many, right? 1 through 9, and it's worksheet from section 1-5. All right.